All right, ladies and gentlemen, today is a discovery lesson. So I'm going to explain it to you, show you where to go, and then I'll have you pause the video, fill out the rest of the worksheet, and then I'll show you kind of observations you should have seen. And then we will talk about it, and then you have a quizzes to practice what you've learned. Just so you know, I know I'm going to on-campus message you this, but the quiz has been moved until Friday. Okay, so we are looking at transformations today, and you want to go to Desmos, www.desmos.com, and you're going to make some discoveries using your graphing calculator. So let's go ahead and go here and see what are we looking at. Well, if I go to, and you actually won't see this yet, if I go to desmos.com, you're going to click on graphing calculator, and you're going to see options on the left. And if you look at the keyboard down on the bottom left, it'll give you different operations you can use. So I'm going to start with f of x equals x squared. So I'm going to type in x squared. Then my second function that I'm first analyzing is what is the function plus 2? Now remember, f of x represents the output. So if I'm saying, what am I supposed to graph on the second line? This is equivalent to x squared plus 2. And so I'm going to go ahead and plug this into my graphing calculator online. So I have x squared plus 2. And then I want to describe the changes. So I can see the graph, the blue graph has been moved up 2 units. So in my discovery, I'm going to go ahead and say it was moved up 2 units. Okay, so that's pretty self-explanatory. If I was going to the next one, then I'm taking the output, which is x squared, and adding 4. So what I would suggest, though, is just erase the one that you have been working with so you can clearly see the change and then see, oh, it's been moved up 4. And then I'll write my observations. One of the things that I've seen that can throw people off is this notation right here. So remember, this is saying now x plus 2 is your new input. So what I'm graphing, since my function is x squared, I'm actually graphing quantity x plus 2 squared and seeing what happens. So in my OneNote, I'm going to go ahead and make sure that I use parentheses and say, what is x plus 2 squared? Could maybe make some predictions before you do it. I would think it would go right 2 units. What? It goes left 2 units, which is one of those tricky things with transformations. So I'm going to go ahead and mark that down, x plus 2 squared, move the graph left 2 units. Okay, I would pause the video. This is best absorbed if you discover it on your own. After you've filled out this chart, resume the video. I'll show you the answers and I will fill out this bottom piece with you. So pause the video. All right, and the answers you can check. Probably some of the harder ones to observe are the ones down here at the bottom. When you multiplied 2 times x squared, you should have seen the graph get skinnier or narrower. But more specifically, I want you to see that the y values increased by 2. In fact, I just want to show you this so that you can see it. So I'm going to go ahead and type in 2x squared. And if I look at the y values, I know it's kind of tricky, but look at this one. This one's at 2, 4. If I look at where did this point move, it moves all the way up here. So the original point on the parent graph, which was at 2, 4, jumped to 2, 8. Or if you're looking at another point like 1, 1, so 1, 1 right here, that one jumped to 1, 2. So that's going to be a more helpful observation. If you didn't notice it right away, it's kind of hard to see, just write it down. But it gets narrower, the y values increased by 2. If you look to the next one, the y values increased by 3. If you put a 1/2 in front of the function, it widens. The y values are going to decrease by a 1/2. And if you think about it, that's because you're taking half of your output, half of your y values. The negative output will flip the graph over the x-axis. You could also say it makes all the y values negative of the original graph. And then f of negative x flips the graph over the y-axis. Okay, check the bottom pieces here. And so we can see again, the y values increase by 2, the y values increase by 3. Pause the video if you need it, but I'm gonna go ahead and fill out this bottom piece, which is important. Rules to know for transformations. If you are adding or subtracting a number to your function, the graph is gonna move up or down. Specifically, if we have, let's see, the graph moves up C units. And if you have f of x minus c, the graph moves down C units. And then if you are changing the input, the graph is going to move either left or right. But the tricky thing is it's the opposite of what we would think. So I think of parentheses as like opposite day. If you're adding a number, that means you're going to go to the left direction. If you're subtracting a number from the input, you're going to go to the right. So the graph is going to move, graph moves opposite day, left C units. And f of x minus c means that the graph moves right C units. Tricky business, but I know you guys can handle it. Then if you have the opposite of f of x, the graph is going to flip upside down. So we say over the x-axis, graph reflects over the x-axis. And if you want more context to that, you're taking the opposite of your output. So all the y values of the original graph are going to be made negative, hence the flip. All y values are made negative. For the next one, f of negative x, this one, the graph is going to flip over the y-axis. Graph flips side to side. Over the y-axis. And if you want some more context to that, all the inputs, all the x values are made negative. All x, but the y's values stay the same, which is hence why we have the flip along the x-axis, or along the y-axis. All x values are made negative of the original graph. If I look at the next piece, if you multiply your function, really the output of your function, by a fraction, the graph is going to widen. We say widen or stretch. Graph widens / stretches. And algebraically, what's happened is your y values are multiplied by a fraction, so they're decreasing. Y values are multiplied by fraction. And then let's see, and I shouldn't say y values, I should say don't worry about the y values. And well, if you don't have any plus or minus changes to it, then really the y values are being stretched. They're multiplied by a fraction. But I'll go ahead, you know what, you don't have to write that. I'll go ahead and expand more on that in the next notes. So then if you multiply by a whole number, visually the graph is going to narrow. So the graph gets skinnier, narrows. Well, we could say by a units, but essentially the graph narrows or gets skinnier. Okay, and the piece about the y is essentially these functions, the original graph, have no numbers added or subtracted. They're the parent function. So when you have the parent function, you can say the y values go up by 2, or the y values decrease by a half. Just kind of things to keep in mind. Okay, go ahead and turn this in, and then you can go to the quizzes and practice what you've learned, and then make sure that you're prepared for that quiz on Friday, and have a great day. Samuel, can you say have a great day?
Have a great day.
Come here, gotta come closer so I can hear you. Say, here, I'll turn the camera on because he's a fun little guy. Where's my camera? I don't know. People have probably turned it off by now. All right. Oh no, I don't think I shared the screen. Maybe I did. I don't think I did. Was I sharing the screen?
It says live on YouTube.
Oh, I wasn't sharing the screen. I have to re-record that.